Welcome back to one of our last sessions for Tuesday. I'm just looking at my world clock here. So it's 7 o'clock in the UK right now, where I am, and there's a storm just outside of my door. So apologies if you can hear rain on my roof. It's 9 p.m. in Cape Town, because they're 2 hours ahead of us at this time of year. And Sydney, they're waking up at the moment at 6 a.m. over there, and it's 11 o'clock in San Francisco. So we've got a wide variety of people across the globe who are able to take part. So we've got our session from Ravi from Daily, our platinum sponsor, up next. And I just wanted to recap our other sponsors, just to drive home the message that you should all be talking to all of these sponsors in the Matrix rooms, because ultimately, if they don't feel as though they've got value for money, they won't be back. So make sure you go talk to them and see what they're all about. So we've got our platinum sponsors: Subspace, Daily, Element, Mux. We've got gold sponsors: Taloo, 100 millisecond site. Silver sponsors: Lowway, Sangoma, Millicast, WebRTC Ventures. And our community sponsors: Jambones, Telecurve, and Pion. And then our AV sponsors: PSP, Millicast, Broadcaster, Subspace, Element, Mux, and Me Echo. So an awful lot of businesses across the globe have come together and supported make this event happen. So I'm going to pass over to Ravi's recording, and then Ravi and I are going to catch up afterwards. So Ravi's going to talk about stuff to do with backgrounds and blurring of backgrounds, but I don't want to ruin his talk. So we're going to go over to that, and I'll see you in about 20 minutes, I think.
Thank you, Dan. Well, welcome to this talk. Thank you for tuning in. Really excited to be here at Virtual ComCon 2021. I'm going to be talking about blurring your video backgrounds and virtual backgrounds. My name is Ravi. I'm an engineer at Daily. We are a WebRTC developer platform. Definitely feel free to reach out to us. You can email me at ravi@daily.co. So today I'm going to talk about background blurs, and hopefully it's something that we're all familiar with, and that we've all used background blurs and virtual backgrounds in the last year and a half, couple of years. In this talk, we're going to go over how these background blurs work. We're going to build our own background blur. We're going to finally integrate this blurred video stream on a WebRTC call. And most importantly, I hope to really talk about background blurs as a template for building similar emerging use cases and applications. And I'm hoping that it sparks new ideas amongst developers and product managers who are really thinking about WebRTC use cases and applications. So with that, let's start by talking about why now. Why this moment in time to talk about machine learning applications on the WebRTC side. I think we're passing through a very interesting and unique window in time. There's a lot of churn and activity and innovation happening. Some new exciting applications are becoming possible for people to create. So starting from somewhere in the middle of 2020, around July, TensorFlow launched a WASM backend. WASM stands for WebAssembly. Why is this a big deal? Because earlier, machine learning inferences were really restricted to running on the GPU, and WASM backend enabled us to run model inferences on the CPU. This meant that these models were run across browsers, also would run on low-end mobile devices that don't have GPUs, and then also compared to native JavaScript, it runs 10 to 20x faster. So this was huge. WebGL is still a preferred option for large size models, but really for small and medium sized models, they're working really well on the CPU with WASM. So this has been one huge step in the development cycle. Secondly, there's been this push right over time to uh, tune these machine learning models to work really, really well in resource constrained environments. So these models are getting smaller, they're getting pruned, and then also quantization, wherein instead of using large floating point numbers, we're kind of moving towards fixed point numbers. So that's sort of enabling machine learning models to run in like memory constrained and resource constrained environments on the edge and also on the browser. Uh, and thirdly, we're also starting to see the emergence of what is really, machine learning model repositories like TensorFlow Hub. AWS now has a model marketplace. So, capabilities that were once really restricted to machine learning and AI, scientists now are becoming widely available to developers. And you don't have to be an ML expert to build some of these applications. All you need to have is sort of a high level understanding of how these models work and what the output looks like. And really, with just these three developments alone, we're already seeing some really cool applications, use cases that run natively from the browser. They're running with really low latencies of less than 20, 30 milliseconds. So this is really, really cool. And what's even more interesting is as we sort of look down the road, SIMD support for WASM is being worked on. SIMD stands for single instruction, multiple data. Basically, it's a way to enable parallel computation on the CPU itself. And as and when SIMD support becomes available for WASM, the models that are already working, decently well, will potentially run 2 to 3x faster. So just stepping back, all of this is just a way to say that machine learning on the CPU is working really well to run inferences. These models are becoming smaller. Models are becoming available to everyone, and these models are going to get even faster down the road. So which is why I believe we should talk more about background blurs, but really use background blur as a template for understanding how we can create custom new other unique video experiences for our customers and users. So let's start by getting a high level, looking at this at a very high level and understand how background blurs work, how these machine learning models work, and just gain an appreciation for what these models are doing. This task in machine learning is called semantic segmentation. It is the task of classifying each pixel on an image, and assigning a category label to it. So this image on screen, this would be a very simple example wherein like each pixel here could be classified as the plane or the sky. So a really simple use case, simple example, only two categories here. There are more complex versions of the same task. Pictured here is real-time semantic segmentation performed on self-driving vehicles camera feed, right? And you can see that each pixel here is now being classified into a much larger set of categories. A pixel can be the road, a person, car, tree, and so many other things. So the same problem, but a more complex version of the same problem that we saw earlier. Let's talk a little bit about these machine learning models, how they're built, and how we would use them. There are two parts to machine learning. One is training a model and building a model. And secondly, you can use a trained model to run predictions or inferences. A neural network like the one in the middle will typically have millions of nodes interconnected, and they'll all have weights associated with each node. They're all processing nodes, and typically the training of the process of training involves giving this model lots of training images like the one on the left side, and also giving it images such as manually labeled images such as the one on the right. And then we kind of iteratively tune the weights in the model such that if given the image on the left, it produces this image on the right. And the other thing I would highlight about these two images is they are the same frame height and width. So it's the same image, but kind of each pixel just now has a different category value assigned to it. And the process of training, really initially these nodes will all have randomly assigned weights, and the training image will be passed in from the left side. you will compute a solution on the right. Initially, you'll have a completely garbage solution, and we will compare it with your desired output solution, calculate a per pixel loss value, and then you take these loss values and back propagate and sort of tune or tweak the weights in the model so that you better or move the output closer to the desired result. And you do this iteratively over a period of time across the same image, and then potentially feed in multiple images. And then you might reach a point wherein the model has reached this right complexity where it can take a generalized image similar to this one, not the exact image, and can start outputting, decent predictions like the one on the right. So this is all about training. Once we have a trained model like this, we could then input a generalized model image or data that the model has not seen before, but is similar to what it was trained on, and then we would still start. We'll still get a decent result on the output side. What we're doing with background blurring is, fundamentally, it's a task of semantic segmentation. You're trying to classify all the pictures, all the pixels on a video frame as whether it belongs to on a person or whether it belongs in the background. So we kind of looked at how machine learning models work and what an output from a selfie segmentation model would look like. Now that we appreciate that, let's try to build our own background blur in this next section. We're going to look at some code snippets. We're using MediaPipe here. MediaPipe is an open source framework for machine learning solutions. The best thing about MediaPipe is that they have these great pre-trained models that are available out of the gate. So I would really encourage people to check out the models there and test them out and play around with them. This image on screen, this is the final output that we're heading towards. Like this is what we want to build. The subject in the foreground is sharp and crisp and clear, and the background has been blurred. And let's look at how we can build this blurred video stream. To begin with, we start by getting the raw camera feed. We use get user media to do that. Most developers would be familiar with get user media. Next, we then initialize our machine learning library and model. We are using the selfie segmentation model from MediaPipe to do this. It segments prominent humans in the scene. It works really well for humans, in a 2 to 3 meter distance from the camera. I've seen it do a fairly decent job, even when people are much further away. But anyway, so we're using selfie segmentation here. Once we have initialized the model, we now need to write a hook wherein you want to send a camera image frame from your video element to the segmentation model. And you can use methods like request animation frame or a web worker to do this. At Daily, we use a web worker to do this because we found it works better when a tab is backgrounded. So in this step, we are now capturing a single camera image frame from our video stream and sending it to the model to run segmentation on. Once we do that, we come to really the most fun part of this entire process, which is, we get to take the results from the model and render a blurred video stream on a canvas. So to start off, we clear the entire canvas, start off with a clear canvas, and we use composite operations to draw the resulting segmentation mask on the canvas. So the segmentation mask is the result being generated from the model to which we sent the image in the previous step. So that is seen here in red, and all the pixels in white that you're seeing it's technically transparent. They're not white per se. So we draw the segmentation mask on the canvas, and then after that, we draw a raw, unprocessed image frame on top of this, only where the mask exists. So this has the effect of effectively, removing the background from the entire image, and you're left with this with this result that you see on screen. Once we've done that, we can then take again a raw, unprocessed image and apply a blur filter throughout. and which would give us this kind of a frame. And then what we do is we slide that frame in behind the crisp frame we'd built a couple of steps back, wherein we had removed the background. So with these things put together, you finally have a background that is blurred. The foreground is nice, crisp, and clear. And really, it's only these many lines of code. We rendering this on the canvas was essentially these 3-4 steps. And hopefully you're seeing that this is not a lot of work, and it's really simple to build something like this. And once we've built a blurred video stream, the last step is integrating this blurred video stream on a WebRTC call. So we use capture stream to do that. And capture stream generates a media stream object from that canvas element, which we can then. So, for instance, in a normal WebRTC call, you'd get the camera stream and you take the media stream and put it out on the WebRTC call, and you just change that process to you take that camera stream and you send it to a video process. The video process in this case runs segmentation. It renders this new blurred stream on a canvas. We capture a stream from that canvas, and then now we send out a processed media stream on the WebRTC call. So instead of sending out the raw media stream, now we're replacing that with this processed media stream. And so really, what have we seen, right? We talked through how background blurs work. We built our own blur using MediaPipe, and now we've integrated that blur video stream on Daily. And hopefully you agree with me in saying that, these aren't too many lines of code. You can easily spend a couple of days and spin up a decent working demo with any of these kind of use cases. And the most important talking point that I wanted to leave everyone with today is really that background blur is merely just one example, and it's just the beginning, right? And the same template that we used to build background blur, we can essentially build any different kinds of, any number of different kinds of use cases and applications that one can think of. And at Daily, we want to kind of enable developers to fully explore, custom video processes. And, if you want to build funny hats, if you want to draw mustaches on people, whatever it is, whatever the use cases might be, we want to enable, we want to enable people to kind of explore these kind of different use cases, so that developers can kind of focus on their video experience that they're creating for their end user, and we can kind of own the WebRTC side of it and enable this. And really, I think with by letting developers really write a couple of functions. One is you want to choose whatever machine learning model that makes sense for your application, and you want to initialize that, and so that part of the code, and then you want to write your own render on canvas method. And if you write these two methods, you can easily take a new video stream and put it on a WebRTC call. And so really the last thing that I wanted to chat with you today, and hopefully the most interesting thing that I want to leave with you today is, what kinds of things can we build with this, right? And what kinds of use cases and demos already exist. And hopefully it seeds some ideas and conversations in whatever part of the application world that you are focused on. So maybe you have a fitness class running on WebRTC and are interested in running post tracking. MediaPipe has a post model, and you can enable experiences like this. These models are working really well with pretty low latencies, and you can enable, I think, a 30 frame per second video pretty easily to do this. Maybe you're interested in joining meetings as as an avatar in a metaverse world. MediaPipe has a face mesh model. It tracks over 450 odd landmarks on your face, and you can kind of take that face mesh and overlay it on an animated frame, and enable people to kind of join as an avatar in a media call, in a video call. Perhaps you're interested in tracking eyeballs, gaze, and attention. Again, there's an iris model in MediaPipe. Definitely encourage people to check it out if that's an idea that is interesting. You could integrate some kinds of gestures in your video call. You can track hand poses. So technically, things like raising your hands, enabling high fives on the call, and things like that. It would be possible to build these kinds of integrations into your video call and the video experience. So really, all in all, what we talked about today, we looked at Blur, how they work. We built our own Blur. We put it on a WebRTC call. But really, I hope that the talk kind of helps to demystify how these experiences can be created, and that Blur is not even the most interesting use case for these kinds of machine learning applications in our video calls. Hopefully, we're going to see some really cool applications right in the near future. And background blur, if anything, is just a template, right? The exact same framework that we use to build a background blur, we can use it to build just about anything we might be interested in doing. So with that, I'll conclude my talk today. Thank you so much for tuning in. I hope you enjoy the rest of the conference and, most importantly, the upcoming holiday season. Again, my name is Ravi. You can reach me at ravi@daily.co. Thank you.
Thanks for that, Ravi. It's a topic that I've always been interested in, but never had the guts to actually go and develop it myself. Yeah, and you've shown that how kind of simple it is to get going. So I'm going to bring Ravi in now instead of talking to him as though he's not here. And so welcome, Ravi. Thank you for the talk. So I guess my first question to you would be, you've shown that it's quite, I don't want to use the word simple, because it's not simple. Like all of the code underneath to actually do all of this stuff isn't simple. But as an end user, you can go in and add like 50 lines of code and have something that really works quite well. So why are there more people like me who still haven't developed virtual backgrounds for their WebRTC applications compared to people that can go off and do it? What do you think is stopping people like me going and doing it?
Yeah, totally. I mean, firstly, I think it's been a changing area. It's been the support on the website for the WASM backend on TensorFlow has been a fairly recent development. And so, to be honest, there are a lot of these applications that are getting built as we speak. Over the last 12 months, a flurry of these kind of virtual backgrounds and background blurs have already shipped. And I think as more and more of these examples get out there and people see examples of codes and snippets and of these things being built, I can only imagine that more and more people will be more encouraged to play around with it. And
the pandemic's really pushed this forward, hasn't it? At a fast rate of knots. Like for a long time, Zoom had it, and at the beginning of the pandemic, like all of these web services suddenly went, "Oh, we've got to beat Zoom." So that's really pushed it along. And I guess the thing that sticks in my head, which isn't true anymore, putting video into a canvas tag and doing stuff with it used to be like slow and bad, and you'd end up. You really had to be very, very careful. Whereas now, with all of the controls that we've got, through WASM and everything else, then we don't have to deal with as much pain anymore. And I guess it's reteaching old brains that these things are now okay, and it's actually relatively simple to go off and do it yourself. And if you're using daily, then it's really very simple to get going and get started with it.
Yeah, no, totally. I mean, in an ideal world, what we would hope for ideally is that, developers can, whatever application that they can imagine they want to build, right? They can choose their own models and they can sort of run inferences on their own models on the video stream. And all they need to really do is write that render on canvas method, right? And once you can and you can customize that in any which way you want. And once you've written that render on canvas method, the process of actually putting it onto a WebRTC call is really, really simple. You can just grab the media stream from that and send it out. So hopefully there are going to be many more of these applications getting built down the road. Uh, the canvas, the all of those rendering on canvas. So on browsers like Chrome and Firefox and all of it, it's been running really well. We've occasionally found some challenges around on certain browsers, kind of getting the same functionality to run, and might need to use some polyfills to enable similar behaviors. But I think all of that gap's also closing quickly. And
I mean, it has to basically, like the more and more like people look at Zoom or MS Teams with their native app and go, well, Zoom does it. Why doesn't your app do it? And that's really helped drive a lot of stuff over the course of the last 18 months. I've lost track of things that people have wanted for a while, and suddenly they got done, or they were already in progress, but they've been sped up to be able to take care of people during the pandemic. So I think that's all that we've got time for today. Do you want to quickly tout your other session that's on Friday?
well, yeah, thank you. And we're really excited to be speaking here at ComCon. On Friday, my colleague Vanessa and I were talking about debugging the RTC calls. And so we've taken a few calls and we've sort of degraded them in controlled ways to recreate some of the common audio and video issues people experience.
And some
So
really good tips in there for how to even get started debugging. Like, I've got this problem, I want to debug it. How on earth do I do that? So that's a really good session, and I think that's our second to last session on Friday. So thank you again, Ravi, and thank you, Daily, for being one of our platinum sponsors. So we're going to take a quick break now, and we'll be back in a minute for our next session. Thank you.